So our next lecture is about the periodic table. Like periodic table is one of the most difficult topics that students find. But I think it is one of the most easiest one, because the first thing that you have to do is to memorize the periodic table. So in this lecture we will discuss all the periodic table and all the periodic trends that you need for IMAT exam. We won't be going into the details that are irrelevant to IMAT, but you have to know that these are the topics and these are the elements that you have to memorize. The first thing is that I will be giving you a mnemonic, but that mnemonic is in my own language, because only students with Urdu and Hindi might be able to understand it. But if you are someone that can speak English, or that is Italian, or that is European, then you can make mnemonics using ChatGPT or Google in your own language, because I think making mnemonics in your own language is much better than making mnemonics in English, or trying to memorize mnemonics from other languages. So the first thing that you have to memorize is the elements from the first block, that is the S block. The first block is saying that hydrogen is the first element, and the elements down below are lithium, sodium, potassium, rubidium, cesium and francium. The mnemonic here is Hali ne ki rab se faryad, and you know that hydrogen, lithium, Hali, hydrogen and lithium, ne ki, sodium and potassium, rab, that is rubidium, se faryad, cesium and francium. And then you have the second portion, that is about beryllium, magnesium, calcium, strontium, barium and radium. You can make it as Badi Maj ka sar bada. Badi means beryllium, Maj means like a cow, and you can say magnesium, and then Ka, that is calcium, Sir, strontium, Bada, that is barium and radium. So that's how you can memorize the S block elements. Now you don't have to memorize all the D block elements. I will tell you what are the D block elements that you have to memorize, then come back to P block elements. The P block elements, the first one is boron family. The boron family contains bengan, aloo, gajar in thela. So like B for bengan, B for boron. So bengan, aloo, that is aluminium, gajar, that is gallium, in, that is indium, in thela, that is thallium. And then you have the carbon family. The carbon family is Sassi, Gai, Sindh, Punjab. Sassi, that is carbon, and silicon, Gai, that is germanium, then Sindh, Punjab, that is tin and antimony, SN or PB, Sindh, Punjab, SN and PB. Then you have nitrogen family. You can memorize it, Nasreen, Parveen, Asma, Sab, Behne. Nitrogen, Nasreen, Parveen is phosphorus, Asma is AF, Sab is SB, and Bismuth is Behne. And then you have oxygen family, that is O Sasi Tera Punnad. That is actually, Punnad is like a family relation. You don't have to like know what is Punnad means, but you have to know O Sasi Tera Punnad, that Sasi is your Punnad. So O Sasi Tera Punnad, oxygen, sulfur, silicon, tellurium and polonium. Then the other family is the halogen family. You have to know that fluorine, chlorine, bromine, iodine. And then you have the noble gases. The noble gases are Hina, Nina or Carina, X-ray. That is, Hina is helium, Nina is neon or is argon, Carina is krypton, X-ray is like xenon and radon. So now you have memorized the major S and P block elements. That was like really easy for you. But you have to also memorize it from left to right. Like you just memorize it from top to bottom. You have also to memorize it from left to right. So if you want to memorize it from left to right, then you just have to memorize 2, 3 and 4. Like these are the most important ones. You don't have to memorize any other element. So these are all the elements that you do to memorize for your IMAT exam. So again, if you are someone that like is really in need to make mnemonics, then make any kind of mnemonic. If you want to, you can repeat this lecture again and again. You can write down all these mnemonics in your register or your notes, like Hali ne ki rab se faryad, Badi Maj ka sar bada, bengan, aloo, gajar in thela, Sassi, Gai, Sindh, Punjab, Nasreen, Parveen, Asma, Sab, Behne, O Sasi Tera Punnad. Then you have fluorine, chlorine, bromine, iodine. You don't need a mnemonic for this. And then Hina, Nina or Carina, X-ray. Like you have memorized the 90% of the portion of the periodic table using like simple mnemonics, right? Really easy peasy. And then you have to memorize it from left to right. Why you have to memorize it from left to right? Because that way you can memorize it in atomic number. Like for example, what is the atomic number for lithium? That is 3. For beryllium it is 4. For boron it is 5. For carbon it is 6. For nitrogen is 7. Oxygen 8. Fluorine 9. Neon is 10. So like you don't even need to memorize the atomic number if you have memorized a periodic table. Neon is 10, then you have sodium, that is 11, magnesium is 12, aluminium is 13, silicon is 14, 15, 16, 17, argon is 18, and then potassium, that is 19, 20, scandium 21, 22, 23, 24, 25, 26, 27, 28, 29 and 30. You have to memorize until zinc. Like these are the most important ones. You don't need to memorize all the elements on the periodic table. You only have to memorize the most important ones. So let's memorize from left to right. The first thing is Libby. You can make any mnemonic you want to, like these are the mnemonics that worked for me. So Libby, Baknu funny. Like Libby said Baknu that you are really funny. So Libby, Baknu funny. Then you have Na Mang. Like Mang means like asking something. Then you have Na Mang. So Mang means like for asking, you are asking for something. You are saying Na Mang Alsi, that don't ask for Alsi pas kal aar, कि pas kal ko आना आप. Like right, you understand my point? Like Na Mang Alsi pas kal aar, like don't ask for Alsi today, you should be coming tomorrow. And then you have Kaka Sikandar, like potassium and calcium Kaka. Sikandar is scandium, TV like selenium and vanadium. करे महंगा, ठीक है, chromium and manganese, like he just raised the prices of TV. फिर कोनी copper zinc, and then you like hit him with your कोनी, right, because he is selling TV at a really high price. So that's how you can mnemonics and memorize this. I will repeat it down again. Libby Baknu funny, Na Mang Alsi Pascal A, Skandar TV करे महंगा, फिर कोनी copper zinc. Like copper zinc is not a part of mnemonic, you can just memorize it as it is. Then you can also memorize here, that is scandium, yttrium, and there is lanthanum right here, that is Shakila, right? Shakila could be you can memorize it here. It is important because you have to know that Shakila is actually important. And then you have to memorize zinc, cadmium and Hg. You can say like Zunaira Sadi hai, ठीक है, like Zunaira is name of a girl and you are saying that Zunaira is Sadi, right? Okay, so Zunaira Sadi hai. So this was the way that you could memorize all the elements and the most important elements on your periodic table. Now you know that like these are the elements that are the most important ones. So even if you are not the one that speaks my language, you can make mnemonics from any language that you are speaking. I don't want you to make mnemonics in English. You can make mnemonics in Italian, you can make it in German or French or any language that you speak, because making mnemonics in your own language is like a plus point. And you know, like in med school, like 90% students make mnemonics to memorize things, because there are so many things, so many nerves, so many muscles, so many bones to memorize. So we make mnemonics to retain all of that data. So I just gave you a short trick to memorize the periodic table, and if you memorized periodic table, then solving MCQs for periodic table are going to be a piece of cake. So now you have memorized the periodic table in a 5 minutes of time. So write down all the mnemonics on your notes, and let's move on to our next topic, that is about there are portions of periodic table. The first is period, group, and then you have blocks. The horizontal rows are called period and the vertical columns are called groups. Everyone knows like what is a period, what is a group, so we won't be wasting time on it. The next we have 4 blocks. The first block is S block, that contains electrons in the S subshell. The P block elements contains electrons in the P subshell. D block elements contains electron in the D subshell, and F block elements contains elements in the F subshell. Let's see what is S block. As you can see, the hydrogen and beryllium family are in the S block, and then this is the P block, and then you have D block, while F block is outside of the periodic table. You have to know that the F and D block elements are actually transition elements. D and F block are called what? Transition elements. And the problem here is that D block elements are called outer transition elements and F block elements are called inner transition elements. That's a bit weird, because D block elements should be called inner transition because they are inside the periodic table, and F block should be called outer transition because they are outside the periodic table. But it is actually opposite. F block are called inner transition and D block are called outer transition, maybe so that F block elements don't feel left behind. Okay, so the color in the periodic table is telling you a lot of things. For example, the pink elements are transition elements, the purple are alkaline earth metals, and then you have alkali metals that are light purple, and then you have metalloids, metals, and then you have noble gases. So the coloring in the periodic table is telling you a lot of many things. You can know like what is the atomic mass, what is the atomic number, what is the element symbol, element name. You don't have to memorize the whole periodic table as I told you before. You only have to memorize the elements that I gave you mnemonics for. Like you have to memorize S block element, P block element, and the first two lines for D block elements. Like you don't have to memorize all the elements, they won't be coming in your IMAT exam. So let's move on to our next topic, that is about the key groups and their names. The first group is called the alkali metals because they are resembling metals that are alkaline in nature. The second group are also alkaline earth metals because they are present in the earth crust, that is why they are called alkaline earth metals. They have two valence electrons, and then we have the boron family. As you can see, it is not that difficult. The first is these are alkali metals, these are alkaline earth metals, they have 2 electrons in their valence shell. Then you have the boron family, they have 4, and then carbon is 4 valence electrons in their outer shell, and then you have nitrogen, they have 5 valence electrons, and then chalcogens, that is oxygen family, they have 6 electrons, and then you have fluorine family that they have 7 electrons. And if you talk about noble gases, they contains 8 electrons, and that's why they are full and they don't need any electrons. They are actually octet is complete, they don't need any more electrons, so they are actually stable. Why they are called noble? What does noble means? Noble means that someone that does not bother anyone, like that is really kind and does not hurt anyone. So are like noble gases. Noble gases does not react with anyone, they don't hurt anyone, they don't like take electrons from anyone. They are like everyone should have their share. I don't need anything from anyone, and I don't need to take anything from anyone, and I don't want to give anything to anyone. Like they are separate from the whole periodic table. That's why they are noble gases. They don't do anything to anyone. Like okay, like they are independent, like strong independent woman, you can say. Okay, so these were the groups and their names and the key properties. You can like memorize this table, but we have already memorized it in our like periodic table. You have already memorized the elements, and now you know that what is the main property here. You have to memorize is the valence electron. You have to know that group 1 contains 1 valence electron, group 2 contains 2 electrons in its outermost shell. Then you have group 13, 14, 15, 16, 17 and 18. They are boron, carbon, nitrogen, oxygen, halogen and noble gases. So you can memorize these. If you have already memorized periodic table, you don't need to memorize like what is the group 15 containing, what is group 16 containing. Just memorize the periodic table and you are good to go. The table will be already done for you. The next thing is about the periodic trends. Like periodic trends, as I told you, like it is the most highest yield topic in IMAT exam. There has been like so many questions from this single topic. So we will be going into a really high detail into this topic because it is one of the most important topic in IMAT. The first thing we will be discussing about is going to be the atomic radius. So first thing that you need to know about atomic radius is that the atomic radius is the distance between nucleus to the outermost electron. So what are the factors that affects the atomic radius, and let's write them down one by one. First thing that you need to know about is what happens when you move from left to right. from left to right, and what happens when you move from top to bottom, right? So these are the things that you need to know from left to right and from top to the bottom. So there are things that you need to understand and there are things that you need to avoid. So first thing that you need to understand is that what happens to the nuclear charge. The first property is about nuclear charge. So when you move from left to right, the nuclear charge actually increases, and when you move from top to bottom, the nuclear charge actually decreases. You will know that reason when we discussed all the properties. The next thing that you have to discuss about is the number of shells. When you move from top to bottom, the number of shells increases, while when you move from left to right, the number of shells will remain the same, while number of shells does not decrease or increase when you move from left to right in a period. What about protons? If you talk about protons, then the number of protons are always going to increase. Like even if you move from top to bottom in a group or left to right in a period, the number of proton will always increase. And if you talk about electrons, the electrons are also the same. The electrons will always increase. Even if you move from top to bottom in a group, they will also increase, and if you move from left to right in a period, they will always increase. And the last property that we will be discussing about is going to be the shielding effect. We will also discuss shielding effect in detail. So if you talk about shielding effect, then the shielding effect will increase when you move from top to bottom, and it will remain the same from left to right. So let's discuss these properties one by one. So as you can see here, that the first thing you have to understand is the number of protons. If you talk about number of protons, then the number of protons are always going to be increasing. The same is the thing for the electrons. The electrons will also always increase, but the thing that makes the most amount of difference is the nuclear charge. Nuclear charge is actually the game changer here. As you can say that when you move from top to bottom, the nuclear charge actually decreases, and when you move from left to right, the nuclear charge actually increases. So what will happen? So what will happen is that when the nuclear charge increases, the nuclear charge will attract the electrons towards itself in higher frequency. Like if there are two positive charges, and if there are two positive charges like this, and they are attracting one electron, then that electron will be attracted more, and the electron will be closer to the nucleus. And if it is one charge, then the electron will be attracted, but it won't be as close as this electron, because this electron will come close to the nucleus like this. But one positive charge might not be able to attract the electron towards itself as much as two positive charges. So when the nuclear charge increases, then you can see that the electrons will be pulled towards the nucleus, and that's how the size, or you can say the atomic radius, will decrease. So when you move from left to right in a period, then what will happen? The atomic radius will actually decrease. And what about top to bottom? When you move from top to bottom, the nuclear charge actually decreases. When the nuclear charge decreases, then the electrons will be go away from the nucleus. When the nuclear charge is less, the positive charge of nucleus will be less, and the electrons will go away from the nucleus. When electrons will go away from the nucleus, then the size or the atomic radius of the atom will increase. So the main factor that is deciding these things is the nuclear charge. So if the atomic radius increase or decrease is mostly dependent upon nuclear charge. Let's talk about the number of shells. If you move from top to bottom, the number of shells increases, but when you move from left to right, the number of shells are not increasing or decreasing, but they remain the same. Why is that? The reason is simple, because the electrons keep adding into the same shell. You have studied about the group and the period. Let's go back to the periodic table. When you move from left to right, as you can see, the number of shells are not changing, like leave be buck no funny. As you can see here, the shell is same, right? The second shell, and in Namang Alsi Pascal are sodium, magnesium, aluminium, silicon, they are in also the number 3. So as you can see, if you move from left to right, the electrons are in the same shell. For example, if you make the atom like this, and this is the same shell, and the electrons will keep adding in the same shell, 1, 2 and 3. But when you move from top to bottom, then a new shell will be added and electrons will be added into the new shell. So that's why when you move from top to bottom, the shell number of shell increases and the electrons will be added in the new shells, and when the shell increases, the atomic radius will start increasing slowly. The next thing is about the number of protons and electrons. The number of protons and electrons, both of them will increase, and they don't actually affect the atomic radius that much, because if there is one proton, then there will also be one electron, so they will cancel out the effect of each other and they won't be like contributing in the atomic radius that much, because proton and electrons are both positive and negative and they will like cancel out the effect of each other. The next thing is about the shielding effect. So what is shielding effect? For example, I have already made the diagram here. As you can see, if you imagine like this is the electron and this is another electron, the nucleus will attract this electron towards itself, and the nucleus will also attract this electron towards itself. The problem is that the first electron will repel the second electron away from the nucleus, and it will kind of shield the second electron from the attractive force of the nucleus. So the first electron will repel the electron and shield this electron from the nucleus. So this effect is called shielding effect. So this, what will happen, when the electron will repel this electron, the electron will go away from the nucleus and the atomic radius will increase. So the shielding effect will cause increase in the size of atomic radius. So that's why if the shielding effect increases, then the atomic radius will also increase. But when you move from left to right in a period, the shielding effect is same. Why is that? Because the reason is simple, because the shell is the same, the shell is not changing. If the shell is same, so the shielding effect will not be like that much in the same shell. For example, these two electrons are present in the same shell, so will they have effect in the same shell? No, they can repel each other in the same shell, because if two electrons are in the same shell, they are like in a relationship with each other, they are like attracted to each other, they are overlapped and they are rotating around each other. You have studied this behavior in quantum numbers and in spin quantum number. The two electrons in an orbital spin in an opposite direction, so they don't cause shielding effect in the same shell. Shielding effect is only possible if the shells are different. If the electrons are in different shells, then the shielding effect will have effect. If they are in the same shell, then the shielding effect will not have any effect. So this was all the properties that affect the atomic radius. So if you have any problem, you can watch the lecture again. If you watch the lecture again, you will understand a lot of things better, because if you watch this lecture for the first time, then so many things might not be really easy for you in this topic. So you can always watch the lecture again and again, so you can understand this topic better. So this was about the atomic radius. We can add other things in the atomic radius too. Let's take some examples. The first example is about atomic ions. There are two atomic ions. The first is anion and then you have cation, right? What is anion? You will get anion whenever an atom accepts an electron, and you will get an cation when an atom loses an electron. So anion will have a negative charge and cation will have a positive charge. For example, if an atom have only one electron in its outermost shell, if the electron is removed, for example, if the electron is removed, now this is the last shell, so technically you can say that the atom just shrank, like the size just decreased, the size shrinked. Why did the size shrink? Because the only electron that was present in the outermost shell just has been removed. When the electron was removed, the atom size decreased, so the atom will have a positive charge. So that's why when you have a cation will have a smaller charge size, and anion will have a larger size. So that's why when an electron is added in an atom, the shielding effect will occur. Like when another electron is added, the already present electrons will repel the new electron from the nucleus, and the size of atom will increase. That's why the size of anion is always greater than cation. Let's add another example, that is van der Waals radius. You can say that van der Waals radius has the highest radius in all of the examples that we will be discussing. So van der Waals radius is the highest radius or the largest radius. Then you have Ionic radius. If anyone has anion, then the Ionic radius is second. Then you have normal or covalent radius, like it is not positive or it is not negative. Then you have cation. If the atom is cation, then it has the smallest radius. So that's the whole comparison. Like van der Waals has the largest size, then anion, then covalent radius, and then cationic radius. So let's close it down in a box like this. So van der Waals radius is highest, then anion, then covalent radius, and then the smallest one is the cationic radius. So these were the concepts that you had to memorize for your IMAT exam for atomic radius. So the atomic radius concept is complete. You are good to go for the next topic. The next topic is about, yes, everybody knows, that is ionization energy. Ionization energy is the energy required to remove 1 mole of electron from gaseous atom. Like you have to know that the definition is really important. You have to remove 1 mole of electron from 1 mole of gaseous atom, not other forms from liquid or solid, but from gaseous atom in ground state, not in excited state. That's why the definition is really important, because even they can ask you MCQs from the definition. I have seen many definitions in IMAT after 2023. After 2023 there has been so many definitions that has been asked in IMAT, so there is a chance that ionization energy definition might come in IMAT exam too. So you have to keep in mind these little points, like 1 mole of electron, 1 mole of gaseous atom, 1 mole gaseous atom in ground state, not excited state, not liquid atoms, not 2 moles of electrons, or like only an electron. You have to be really specific about 1 mole electron in gaseous atom and in ground state. So when an electron is removed, an energy is required. That's why ionization energy is always endothermic. Ionization energy can never be exothermic. You can say that ionization energy is always endothermic. It is never exothermic. Always energy is required, energy is absorbed by the atom when an ionization energy happens. As you can see, X was a neutral atom, and when an electron was removed, it had positive charge. It was in gaseous stage, and energy was required, and energy was absorbed by the atom. So if we talk about the trend, the ionization energy actually increases across a period and it decreases down a group. Why is that? The reason is simple, because ionization energy always increases when the atomic size is small. For example, if you have a small atom like this is the nucleus and this is the electron. The nucleus will attract electron towards itself, and if if the electron is far away from the nucleus like this, then the force of attraction of the nucleus will be weaker. So the second nucleus will have hard time to retain the electron, and you can easily remove this electron, while removing this electron is a bit harder. You will need more energy to remove this electron, and you will need less energy to remove this electron. So that's why in the first case, in which the atomic radius is small, you will need high ionization energy, and in the case in which the electron is far away and the size is large, you will need low ionization energy. So that's why when you move across a period, you know that atomic size, atomic radius decreases. When atomic size decreases, ionization energy increases, and when you move down a group, the atomic size actually increases. When atomic size increases, electron will go away from the nucleus and you will need less ionization energy. So across a period, ionization energy increases, and down the group, ionization energy decreases. Let's talk about other properties for ionization energy. Ionization energy is directly proportional to the nuclear charge. If the nuclear charge is high, the nucleus will attract the electrons with much higher, stronger force of attraction, and you will need more energy to remove the electron. Ionization energy is also directly proportional to the stability. If the atom is stable and the electrons are stable, then removing electrons from a stable atom will be really hard. For example, if the atom has duplet or octet rule, then removing electron will be really difficult. Like noble gases are the most stable, so that's why you need really high amount of energy to remove electrons. Then for size, ionization energy is inversely proportional to the size. If the size is large, for high atomic radius, the ionization energy is low because electron can be removed really easily. If you talk about the shielding effect, it is inversely proportional. Why is that? Because shielding effect cause increase in the atomic radius. If the electrons shield each other, then they will repel each other and the atomic size will increase. When the atomic size increase, the ionization energy decreases. So these are all the factors that decides the ionization energy, and let's close them down into a box. So these are the all factors that decides ionization energy. If we talk about penetration effect, so what is penetration effect? Like if electrons penetrate an atom, then the penetration effect could be written down as for S, P, D and F. So the atom that has electron in S shell will have the highest penetration effect, and then the electrons in P shell will have less penetration effect than D shell and then F subshell. So the penetration effect you can see here is that for ionization energy is from S has the highest and F has the lowest. The reason is that the S subshell is the closest to the nucleus. Like S subshell containing electrons are closest to the nucleus, and then in the next shell you have P, and in the next shell you have D subshell, and in the fourth subshell you have F electrons. So that's why F is far away from the nucleus and S is closer to the nucleus. That's why S has the highest penetration effect and the highest ionization energy. So let's talk about some exceptional cases. Like exceptional cases are the like gold mine and the ones that are the most trickiest ones. So the first thing that you need to know about ionization energy is that which elements have the maximum and which has the minimum ionization energy. First thing you need to know is that the maximum ionization energy is for 8A elements, right? What are 8A elements? 8A elements are noble gases. As you know that noble gases are the most stable elements in the periodic table. So that's why removing electrons from really stable elements are really difficult. So Hina, Nina, Carina, Xenon, Radon, they have really high ionization energy. And if you talk about the minimum, then the first A group elements have the minimum ionization energy. They have one electron in their valence shell and they can easily lose that electron. So this was the thing that I thought maybe you should know. So let's talk about exceptional cases. The exceptional case for ionization energy is actually there are two exceptions. The first exception or the abnormality is in the 3 elements and in the 6 elements. So 3A and 6A elements, they are the ones that show abnormality, or you can say they are the exceptional cases. The abnormality or the exceptional cases are shown by 3A and 6A elements. What is the reason? If we make a graph, let's make a graph first and then we will discuss these examples. The first thing that we'll make in this graph is about elements. Let's start with lithium. As you can say that lithium is the first element. Then you have beryllium, right? The ionization energy should be increasing. This is a graph for ionization energy. Then the graph should go up, but the graph goes down for boron, and then it goes above again. Then you have carbon, and then it goes above again. Then you have nitrogen, but it goes down. That is an exception. You have oxygen, and then it goes up again. Then you have fluorine, and then it goes above. That is neon. So as you can see, the graph should have been going smoothly upward, but you saw two exceptions. The first exception was beryllium and boron. Beryllium and boron showed you the first exception, right? The next exception was nitrogen and oxygen. They showed the second exception. Let's draw another example. The other example could be, you can write down from again, Libi Baknufani Namang Alsi. Now you have sodium, right? I have already memorized the periodic table, so I don't have any problem writing down these graphs. So sodium, and then the graph should go up. Then you will have magnesium, right? Then the graph should go up, but the graph, instead of going up, it goes down, and then you have aluminium. Then the graph goes up, you have silicon, and it goes up again, you have phosphorus, but instead of going up, it goes down again for sulfur, and then it goes up again, chlorine, and then up again you have argon and stuff like that. So as you can see, the exception here again is magnesium and aluminium and phosphorus and sulfur. So as you can see, beryllium and magnesium are in the same group. Beryllium magnesium badi much ka asar bada, beryllium magnesium calcium, and boron and aluminium are in same group. Boron, aluminium, indium, thallium, and nitrogen and phosphorus are in the same group. Nitrogen, phosphorus, and you have As, like they are in the same group, and then you have oxygen and sulfur in the same group. So this pattern is like repeating again and again. If you make more graphs, this pattern will repeat again. So what is happening here? What is the abnormality? Why is it happening? So the reason here is that the first reason is about 2A elements. 2A elements has electrons in S subshell, while 3A elements has electrons in the p orbital. So it has S electrons and it has p electrons. So why is that like a bit weird? The weird thing is that beryllium, for example, take beryllium. Beryllium has 4 electrons. It will have electronic configuration of what will it be? Beryllium has 4 electrons. Its electronic configuration would be 1s2, 2s2. As you can see, 2s2 is really stable, right? It has a duplet completed here. And if we talk about three elements. The three elements is boron. The boron has electronic configuration for 5 elements. It has 1s2, 2s2 and 2p1. It has the last electron in p orbital. So if I ask you which of these one will have easier to remove electron, can you remove electron from s orbital easily or p orbital easily? You will say that it is easy to remove electron from p because it has only one electron, while in s2s2 it is difficult because it has complete duplet. Its duplet is complete, it is stable, so it don't want to lose an electron, while p has a single electron. It will easily lose the electron and you will have 1s2 2s2 stable configuration for boron. So that's why in the graph it was the reason that 2a has higher ionization energy than 3 elements. So that was the reason 2a has higher electronic ionization energy than 3a elements. Let me write it down for you. 2a has greater than 3a. If we talk about the other example, what is the other example? The other example is about 5a and 6a elements. So if we talk about nitrogen and oxygen, let's talk about nitrogen and oxygen. The reason is, first of all, the reason is that 5a elements has half filled subshell. We have already discussed in our last lecture in atomic number that the element or the atom that have half filled subshell is stable, or if it has a full filled subshell then it is also stable. So 5a have half filled subshell, that is why it is more stable than 6a. Let's write down the electronic configuration. Nitrogen has 7 electrons. Its electronic configuration would be 1s2, 2s2 and then you will have 2p3, right? You know that p orbital has 6 electron and it has half filled subshell. It will have 2px1, it will have px1, py1 and pz1. But if we talk about oxygen, oxygen will have 1s2, 2s2 and then 2p4. As you can see here, the problem here is that the oxygen atom does not have half filled orbital. Instead it has 4 electrons. Then 1 electron will come here for oxygen, right? Then px of oxygen will have 2 electron in px, while the nitrogen will have 1 electron in px. Nitrogen will have 1 electron, but oxygen has 2 1 electron. So because of this 1 electron, the oxygen will have less stable electronic configuration, while nitrogen will have more stable electronic configuration. So this is the reason that 5a has like this. 5a has more ionization energy than 6a elements. So these were the exceptional cases that you had to memorize, and I just gave you the reasons why these are exceptions, the abnormalities, and these are the only exception that you need to know. The table has already summarized all the points. For example, group 2, beryllium and boron, nitrogen, oxygen, they have different electronic ionization energy than they should have. Like oxygen should have been more ionization energy than nitrogen, but it has low ionization energy than nitrogen. You know the reason, because nitrogen have half filled electronic configuration, and boron should have been more than beryllium, but it is less than beryllium. The reason is because beryllium has duplet in its last subshell. It is more stable than boron. That's why beryllium has more ionization energy. So this was all about the ionization energy and the exceptional cases. Now ionization energy topic is complete. You don't need anything else to understand in ionization energy more than this. Let's talk about the electron affinity. What is electron affinity? So electron affinity is the energy for an atom to gain one electron. In ionization energy, we lose electron, while in electron affinity we are gaining one electron, and it will form a negative ion, and it is also for a gaseous atom. So first of all, just like ionization energy, let's write down the properties for electron affinity. Just like ionization energy, electron affinity has the same trend. The same trend for ionization energy will be used for electron affinity. You don't need to memorize different trend for electron affinity. Electron affinity and ionization energy has same trend, but I will be writing down everything here. Electron affinity is directly proportional to nuclear charge, just like ionization energy. Electron affinity is inversely proportional to the stability. Wow, this is different than ionization energy. In ionization energy, we studied about that ionization energy is directly proportional to stability, but electron affinity is inversely proportional to stability, because in electron affinity we are adding one electron. So it is really easy to add electron in an unstable atom, but it is really difficult to add electron in a stable atom. So if we talk about size and shielding effect, it is same as ionization energy. It is inversely proportional to size, and it is also inversely proportional to the shielding effect, just like ionization energy. So this was about the dependence for electron affinity. So if we talk about electron affinity, when electron affinity is maximum and when is it minimum. So first of all, the electron affinity is maximum for 7a elements. Whoa, that is also different. We talked about that ionization energy is maximum for ionization energy is 8a elements, but why is not that 8a elements has maximum electron affinity? The reason is that you cannot add an electron in 8a elements, because you know that 8a elements are noble gases. So the electron affinity for 8a elements is 0. So electron affinity is 0 for 8a elements, right? And if you talk about what is minimum electron affinity, so minimum is for 1a elements. 1a elements have minimum electron affinity. There is a trick question here, that what if they ask you like which of the following has minimum electron affinity? The options is 3a, 2a, 1a and 8a. Then obviously the answer would be 8a, because 8a has 0 electron affinity. 1a has really minor electron affinity, but it still has electron affinity, but 8a's have no electron affinity at all. So the option should be 8a. But if 8a is not the option, like if they are not talking about 8a, then the option is obviously going to be 1a. So the minimum electron affinity is for 1a, and then 2a, 3a, 4a, 5a, 6a, 7a. 7a has maximum electron affinity, and 8a has 0 electron affinity, because 8a does not accept electrons at all, and they have already complete duplet and octet, and they are already stable. So if we talk about exceptions for electron affinity, before we talk about exceptions, there is a table that you need to memorize. The table is chlorine, bromine, fluorine and iodine. So this is the sequence for electron affinity. Chlorine has the highest electron affinity, bromine molecule has low, then fluorine has less, and then iodine has the lowest electron affinity. You don't need to know the reason behind this, you just need to memorize it, because it is really complex and this is an exceptional case. And you need to know that this is same for bond energy. Like if you ever get the MCQs about bond energy is the energy required to break the bonds between two atoms. So this sequence is also same for bond energy. Like Cl2 will have highest bond energy, then bromine, and then fluorine, and then iodine. And if we talk about electron affinity, Cl2 has highest electron affinity and iodine has lowest electron affinity. This is an exceptional case. Write it down in your notes and just memorize it. If we talk about other exceptional cases, then the exceptional cases are 2a, 5a, and 8a. As you know that 8a has 0 electron affinity, right? So that's why it is an exceptional case. If we talk about 2a elements, just we talked about before in ionization energy, they have electrons in s subshell. That's why they are an exceptional case for electron affinity. Just like in ionization energy, 2a has higher electron affinity than 3a. If we talk about 5a has greater electron affinity than 6a. As you know that they have electronic configuration of ns2, 2px1, 2py1, and 2pz1. They have half filled subshell of p. Like p has 3 electrons, they don't have. If a subshell have complete subshell or a half filled subshell, then it will be stable. If p subshell had 6 electrons, then it was more stable. But if it has half subshell, then it is it is stable, but it is less stable than full filled. And if there is an other possibility other than half filled and full filled, then that is like much less stable than half filled and full filled subshells. So that was all about electron affinity. Just like ionization energy, electron affinity had same abnormalities. So this was about the abnormalities of electron affinity. So this was the abnormalities or the exceptional cases of electron affinity. Let's go to our last topic, that is about electronegativity. So electronegativity is the ability of an atom to attract electron pairs towards itself. Like the more electronegative an atom is, the more ability it has to attract a pair of electrons towards itself. If we talk about electronegativity, the first thing that you need to know is that it has no units. Like it is just a comparison. Ionization energy had a unit that was joule. Electron affinity also had energy, it was joule. But electronegativity has no units. You have to know that it is just a comparison, it is just a property, so it has no units. The next thing is you need to know that is the maximum value for electronegativity is for 7 elements, right? Because they have 7 valence shell electron and they are the most hungry ones for electrons. Like they need only 1 electrons to complete their octet. So they are like, give us electrons and we will be rich, we will be the top of the world, we will be invincible, right? So if they have completed their octet, then they will be really stable, just like noble gases. So every element in the periodic table want to be like noble gases. Like noble gases are the role model of all the elements. So every element want to be just like noble gases. So 7 elements have only 1 electron in their subshells. So they only need 1 electron to become like a noble gas. If we talk about the trend, so we will talk about trend at the end for electronegativity. If we talk about electronegativity, then let's write down some really most important elements that are most frequently used in IMAT. The most important elements that are frequently used, that have been used many times in IMAT, are like fluorine, oxygen, nitrogen, chlorine, and carbon. Like these elements are asked or used so many times in IMAT. That's why you need to know the electronegativity for these elements. So the most electronegative elements in these elements is fluorine. So fluorine is the most electronegative, then oxygen, then nitrogen, then chlorine, and then carbon is the least electronegative among these elements. So this was important because if you know this table or this comparison, you can know a lot of things in your MCQs. While we will be solving these kind of MCQs, you will understand why I told you to memorize this, because it will help you out a lot while you are solving IMAT MCQs related to electronegativity. If you're talking about electronegativity, there are things that you need to know. The first thing that you need to know about electronegativity is that if electronegativity is greater than 1.7, and what if the electronegativity is less than 1.7, and what if the electronegativity is equal to 1.7. Like, these are the three possibilities that can happen in your IMAT exam. They can ask you about what if two elements have electronegativity that is greater than 1.7, and what if two elements have electronegativity that is less than 1.7, and what if two elements have electronegativity that is equal to 1.7. For example, there are two elements like sodium and chlorine. They have electronegativity higher than 1.7, so they will form ionic bond. So that's why if the electronegativity difference is higher than 1.7, it will form ionic bond. If the electronegativity difference is less than 1.7, then you have two cases. If the electronegativity difference is less than 1.7, if the electronegativity difference is less than 1.7 and greater than 0.5, then you will have a polar covalent bond. But if you have electronegativity that is equal to or less than 0.5, then you will have non-polar covalent bond. So these are the things that you have to memorize. So if the electronegativity difference is greater than 1.7, like for example, if atom like sodium has really low electronegativity and chlorine has really high electronegativity, so what will happen? The low electronegative element will lose electron and high electronegative element will gain electron. So what will happen? That electron will be going from sodium to chlorine, because chlorine have really high electronegativity and sodium has really low electronegativity. Then the ionic bond will happen. But what if the electronegativity difference is not that high? For example, carbon and hydrogen, they will form covalent bond and they will share electrons. The electron will not go towards carbon or it will not go towards hydrogen that much. So they will share electrons, and there could be two type of sharing. For example, even if you are sharing your tiffin with your classmate, and if you are both of you are same in size, you will eat half, your friend will eat the lunch and half the lunch will be eaten by you. But what if you are eating your lunch with Jian, right? Jian will eat like 70% of the lunch and you will get only 30% of the lunch. So in that case, you will have a partial positive charge on one atom and partial negative charge on another atom. And in that case, the partial positive charge is because that atom had lost the electron, and partial positive negative charge means that the other atom has gained the electrons. Actually, I wrote it down opposite. Carbon would have a partial positive and will have a partial positive. So this was about polar covalent bond. But if both of them are equal, like carbon and carbon, then they will form non-polar covalent bond, because they will be sharing electrons equally with each other. While in polar covalent bond, they will not be sharing equally. One will get more portion and the other will get less portion. So the sharing could be two types. The first sharing is polar, in which one will get more share and the other will get less share. In non-polar covalent bond, both will get equal sharing of electrons. So this was about polar covalent bond, non-polar covalent bond, ionic bond. And what if the electronegativity difference is equal to 1.7? So it could be ionic plus covalent, like it will be ionic and covalent both at the same time. So we will know that like how much is ionic, how much is covalent. So electronegativity difference will decide how much it is covalent, how much it is negative. We won't be going into the detail because it is not relevant to your IMAT exam. So this was the thing that you had to know. So if the electronegativity difference is greater than 1.7, you know that like one chlorine is really strong and sodium is really weak. Chlorine will get all the electrons, sodium will lose all the electrons. But if the electronegativity difference is not greater than 1.7, it is less than 1.7, then both atoms will share electrons with each other. But the sharing could be equal and unequal. If the both are of same type, then they will share the electrons equally and the bond will be non-polar covalent bond, right? But if the electrons are not shared equally and one atom is slightly stronger and the other atom is slightly weaker in electronegativity, then what will happen? They will form a polar covalent bond. So this was all about electronegativity and their specific point that you have to memorize. So keep these points in mind while solving your IMAT exam. So this was all about the periodic trends, and let's summarize all the trends into one summary. This is the summary. You can take the screenshot of this table. It is better to understand this table in a diagram. Like visual learning is the best kind of learning, right? So if we write down all the periodic trends at one place, you can see that atomic radius is increasing from top to bottom. If you go from top to bottom, then atomic radius will increase, and if you go from left to right, the atomic radius will decrease. But wait a minute, the diagram is showing that if you go from left to right like this, the atomic radius will decrease. If you go from left to right, then atomic radius will decrease. But if you move from right to left, the atomic radius will go opposite, it will increase. So you have to keep in mind, if they are talking about top to bottom, bottom to top, left to right and right to left, these are the specific wordings that make so many students confused. So this table is the one that you have to know. Like atomic radius across the period, if you move from left to right, it decreases, and if you move from right to left, it increases. If you move down the group from top to bottom, it increases, and if you go from bottom to top, then it increases. But let's say about ionization energy, electronegativity and electron affinity. They have the same trend. Ionization energy, electronegativity and electron affinity have same trend. If we move from left to right, ionization energy will increase, electronegativity will increase, and electron affinity will also increase. If we move from top to bottom, then ionization energy will decrease, electronegativity will decrease, and electron affinity will also decrease. We have already discussed the reason ionization energy decreases because the atomic size increase. Electronegativity decrease because atom size will increase. If the atom size increases, then the electron will go far away from the nucleus, and it becomes easier to lose the electron than to gain the electron. And if we talk about electron affinity, if the size increases, then the electron affinity will also decreases and it will have less negative charge. If we talk about metallic character, so metallic character is also really important. So metallic character, if we move from left to right, the metallic character actually decreases. The thing about metallic character and atomic radius is that they are interconnected. So the only things that decreases across the period are atomic radius and metallic character, and all the other characters are increasing. So you can just memorize it in this way. Like you don't have to revise the whole concept in your mind, you can just use this short trick. Like if you move from left to right, atomic radius and metallic character decreases, all other things are increasing. If you move from top to bottom, atomic radius and metallic character increases, all other things will decrease. If you see the graph here, the graph is telling you the same thing. If you move from left to right, electronegativity is increasing. If you move from bottom to top, electronegativity also increases. If you move from top to bottom, then the electronegativity will decrease. So these are the things you have to keep in mind. The thing I am telling you again and again, you have to keep in mind if they are talking about left to right or right to left, if they are talking about top to bottom or bottom to top, because these kind of MCQs are really like, you know, tricky questions, and most of the students get these kind of MCQs wrong. So these kind of concepts are the concepts that I don't need to tell you. You can make a mind map in your mind and you can do these kind of MCQs really easily. So the trick to solve this kind of question is read the statement carefully, for God's sake, okay? Like, read the statement carefully and then read the options carefully. If you have read the statement and read the options carefully, you have already solved 80% of the MCQs, believe me. Like 80% of the solution of the MCQs is just reading the statement carefully. And if you read the statement carefully, then you are already like 80% ahead of so many students, because students sees the statement and they're like, oh, atomic radius in period, atomic radius decreases. No, in period atomic radius not always decreases. If they talk about left to right in a period, then the atomic radius obviously decrease. But if they talk about right to left in a period, then the atomic radius will increase. So for God's sake, read the words, read the statement really carefully. You have to know if the statement is in Celsius, is it in Kelvin, what is the unit, what they are talking about, what is the concept behind it. Then take your time. No one is behind you and they have a stick behind you and they are telling you you have to solve the exam 30 minutes before the timer. You just have to solve the exam exactly according to time, not early, not late. So you have to learn the time management. So this was all about from this lecture. This lecture was like, you know, really fun, and it was difficult for some students. It might be easier for some students, and if you are still skeptical for some concepts, I recommend you to revise the lecture again, take the whole lecture again. Recordings has the benefit you can watch the lecture again and again until you understand the topic. So this was all from my side for this lecture. So take care, bye bye.